Hello, today we're going to look at a problem and we're going to use position vectors and the magnitude of vectors to help us. So the problem is, we've got this, imagine this is a river flowing down here, and we've got a boy who wants to swim from point A, one side of the river, to point B on the other side of the river. And he wants to know how wide it is, how far he's got to swim. So we don't have a lot of information just now, but if we say we put in some axes, so your x and y axes, and let's give A the point, we'll call that 5, now remember this isn't to scale, 520, and B we're going to call the point 25, 35. So imagine those in meters. Right, if we were going to find out the width from A to B with these coordinates, one way which you could do it is to form a right angled triangle and use Pythagoras. So we could do this. So find the distance here, the horizontal distance. That's look at your x coordinates. So 25, subtract 5, that's 20. So it's going to be 20 meters horizontally. And vertically, we're going from 35, we're going from 20 to 35, so 35 minus 20, that's 15. So if we want to find that magnitude, or the distance from A to B, we could use Pythagoras. So AB squared equals 20 squared plus 15 squared, and the arithmetic 400, 225, add together, 625, remember that's squared, so we take the square root, so AB square root of 625, that's 25, and we'll call the units 25 meters. Now we've not used vectors there to help us at all, but we could use vectors, and I'll show you how over here. So I'm going to draw the axis again. I'll certainly start that axis again, that wasn't very straight, and neither's that one, so try one more time. There we go, x and y. Now I'm going to get rid of the river, I'm just going to take the points, use the points. So we've got point A there, and we've got the point B here. And again we're looking for this distance here. Right, now we could use the vector AB to help us. So wait a minute, what have we got? We've got the points. Let me put in the points again. So it's 520 for point A, and it was point 25. 0.25, 35 for B. Now, what we're going to do, we're going to use a thing called position vectors to help us. And our position vector is the vector from the origin to the point. So for instance, this position vector here, let's go up to B actually. So O, or from the origin to B, that is called position vector B. So position vector is simply a vector from the origin to whatever point you're concerned with. So O to B, I'm going to label that little b. O to A, that's going to be little a. Now if we want to get from A to B, another way of doing that is going A to O plus O to B. So if I write that down here, so A to B is the same as going from A to O plus O to B. So we're going A to B, but just a longer way. So A to B, same as A to O plus O to B. Now, remembering our position vector, A, that's from O to A. So from O to A is position vector A. Therefore, from A to O, it's the opposite direction. So it's going to be negative A. So A to O, negative A. O to B, that's our position vector B. And generally, we write that round the other way. So we get B subtract A. And whenever you're asked for a position vector, so A to B, or let's say E to F, you always take this last letter here. So in this case, F, subtract the first letter. So subtract here. Back up here, last letter, position vector B, subtract first letter, position vector A. Right, let me get back to the problem we're dealing with here. So remember, we're trying to find the distance from A to B, and we've got A to B is position vector B subtract position vector A. So position vector B, that is the coordinates of B, essentially, written this way. So these are called coordinates. Those are your Cartesian coordinates. If we write them in this form, it means virtually the same thing. These are components, or vector components. And position vector A, 520. Subtract the x coordinates, so we get 20. Subtract the y coordinates, 15. And what we're looking for is the distance from A to B. Or another way of expressing that is the magnitude. And that's the way we write the magnitude, with the lines at both sides. So when we do that, it's very much back up into this problem now, or this area, where we're looking at Pythagoras. So when we've got these components, we can apply Pythagoras to them. So it's just exactly the same as here below. So we get the 20 squared plus your 15 squared, those are your components, square root of 625. I'll just try and squeeze this in. It's exactly the same as that, square root 65, 25. So we get exactly the same answer. So with this problem, you could have used Pythagoras, absolutely no problem at all. Or you could have looked at it in terms of position vectors. Goodbye, and thanks for watching.